Students, today we'll discuss DFA. DFA means deterministic finite automata. Okay, so what is the main definition means? For every input, see, for every input will take only one transaction and it should take transaction. Okay, that is DFA. Now DFA have 5 tuples. Here Q means finite number of states. It's a states. Epsilon means summation symbol means it is a input symbol. Delta means it's a function, transaction function, from where to where transaction is taking place, that transaction function. And Q0 is a start state and F is a final state. Okay, final state is also called as a accepting state. Now coming to the DFA. So we'll see one simple example of DFA. Okay, draw a DFA to accept a string of A's having at least one A. Means the string should contain at least one A. So which first step is identify the minimum string A. Here it should contain minimum one A in our string. Then identify the alphabets. There is only one alphabet, that is A. Now we have to construct the skeleton for the DFA. Here it is a starting symbol. Arrow indicates starting symbol. This is a state Q0 and this is a Q1. Here it is taking transaction from Q0 to Q1 for the input symbol A. Okay, and double circle indicates accept or a final state. Okay, now see, for DFA it should take transaction for every input. So this is a simple skeleton. Then the next step, we should identify the transaction for Q1 also. So for Q1, see here, since after one A any number of A's can be accepted, so here it contains Q0 as a start and it is taking transaction for A, and Q1 is accepting state which is taking any number of A. So this type of representation is called as a transaction diagram. Okay, so transition diagram, and for this one we have to write the definition. Here we have already discussed it contains 5 tuples. Q means states. States means here Q0 and Q1. Okay, Q0 and Q1 our states. Here input symbol, that is A. Okay, and transaction function, that no need to represent. Q0 starting state which is having the arrow, that is Q0. So Q0 is our starting state and F is our final state, double circle state, that is Q1. Okay, so this is how we have to represent the definition. Now coming to the transaction table. This is called transaction table. Transaction function input symbol we have to write, and here only two states are there, Q0 and Q1, that we have to write down, and arrow indicates the starting state and star indicates the final state. Okay, now for Q0 state taking transaction for A. See here Q0 is taking transaction for A and it is going to Q1, so your state changes to Q1. Similarly Q1 for A it is taking transaction to itself, that is Q1. Now if you see what are the inputs it will accept, means it will accept A. Okay, it will accept A or any number of A's. Okay, because your loop is there, it can take any number of A's, and this can be represented as a regular expression. See, any number of A's can be represented by A star. Okay, A star, but here one A is present. Loop means A star, one more A, this is A and this is loop A star. A star can be represented as A plus in the regular expression. Okay, so this is for regular expression, third chapter. Now if they are asked to construct the DFA, till here you have to do. Okay, you have to draw a diagram, definition and transaction table. Okay, coming to the next part. See, some states which is not reachable, or if it is reachable it cannot come back to the accepting state. That state is called as a trap state. A state for which there exists a transition. Here you see starting state, it is taking transition from B as a loop, and for A it is taking to transition for other state. Okay, again for Q1 for B it is taking loop, for A it is taking transition to Q2, and here Q2 is taking transaction loop for A and B itself to itself. But here you see here we will start from here and it should end in the accepting state. Okay, so start from the start state, it should end in the accepting state. That is our transaction. Okay, so here if it reach to q2, if it reach to q2, it cannot reach back to q1. If it reach back to q1, then only that string is said to be a accepted state. Otherwise that string is not accepted. Okay, so hence here q2 is not reachable back to accepted state, so this type of states is called as a trap or a dead state. Okay, so this is the main thing you should know here. So we'll see one example related to this now. Okay, see this example. Draw a DFA to accept a string of A's and B's which do not end with ABAB. Okay, so our string should end with AB. Means it may contain any value before that. Okay, it may contain any value, but it should not end with the ending string. The last value should not contain ABB. Okay, so it should read all other type of string but not ending with ABB. So they are given the input symbol as A and B. So we have to write the string ABB. See, ending, they are given 3 states as a final state. Double circle indicates the final state, and the last state they are created as a trap state. So that if it reached B again, ABB was reached, then here it will be trap, it will not be accepted. Okay, so like that we have to now construct the diagram. See, DFA means it should take the transaction for every input. Now Q0 is having the transaction for A but is not having the transaction for B. So they are looping the transaction for B. Okay, so starting state, loop for B and A, over. Now Q1. See, Q1 for B it is taking transaction. For A we have to include. So A was again looped. See, here we have to draw according to the input, according to the question. Okay, the final thing is it should accept the string which they are given, or it should not accept the string which they are given. So based on the question you have to design it so that it should accept all other strings. Okay, now coming to this one, Q2 is having transaction for B but not having transaction for A. So they have taken A this side. Okay, now for B, if it comes back B here, now Q3 should take transaction for A and B. So A and B. Okay, so it is taking transaction for A to here and B to here. What is our question? It should not end with ABB. Now you see the final state, ending state is here. So the example strings may be, this is also starting and final. No, it may contain no empty string also it may contain, or it may contain any number of B's, or it may contain any number of B's with A and any number of A's with B. Okay, but not double B. Again, if it comes here, if it comes back, then again AB, like a loop it may take. Okay, then if it comes to Q3, see, if it comes to Q3, it will come B here, then A. Okay, then A, then BB, then A, then BB. But this is not the final state, so our string will end here or here or here. Okay, so it will not ending with ABB. So like this you should design the DFA. Okay, now for this one you should write the definition. So states here are QR 1, 2, 3, 4. Okay, Q0, Q1, Q2, Q3, input symbol and ARB, starting symbol arrow, that is Q0, and final state, there are 3 double circle states now that you should write here, Q0, Q1 and Q2. Okay, same way you should write the transaction table. So transaction table here, 3 starting as well as final state you should mention, starting as an arrow and final state with the star. Okay, and Q0 for A it is taking transition to Q1, Q0 for B it is taking transition to Q0. Okay, same way Q1 for A, Q1 for B, Q2, and Q2 for A, Q1, and Q2 for B, Q3. Again Q3 for A it is Q1 and Q3 for B it is Q0. Okay, now you may ask why this B is taken this side. See, if the B was given here, okay, see B, B, B. If B comes here, this arrow, if it comes here, it may take A, B, B. It may end like that. So that's why they have taken it out, so that one more A will be came into the string. Okay, so that's how you should keep in mind while designing the DFA. You should not end with ABB in any way. Okay.